Session 8.4 Testing a claim about a standard deviation or variance. These sessions, we will learn how to do the hypothesis testing for standard deviation or the variance. First, look at the requirement. Sample is a simple random sample. And also the original population has a normal distribution. Okay, look at the notation. N is a sample size, S is sample standard deviation, S squared, this is sample variance. And we have the sigma, that's a population standard deviation. Sigma squared, that's a population variance. And then we have the formula for the test statistic. Okay, so this is the formula for the test statistic. You can see there's a chi-square, means we're going to use the chi-square distribution. And then the degree of freedom, that will be n minus 1. Okay, this is how you guys use your calculator to find the p-value. Okay, and remember this is working with the chi-square distribution. So remind you guys, for the chi-square distribution, this is always skewed to the right. Okay, skewed to the right. And the distribution is always positive. They're starting from 0 here, and then the number is going to be increasing. Okay, skewed to the right and always positive. And when you want to find the p-value similar to the normal CDF or TCDF, go to the second distribution. Choose chi-square CDF. This is talking about chi-square cumulative area. And you're going to plug in the lower value, upper value, and also the degree of freedom. Degree of freedom, that will be n minus 1. So for the left tail test, if I have a left tail test and I want to find the p-value, okay, use the test statistic to find the p-value. I'll be starting with the 0. Okay, we don't start with the negative 1e99 because chi-square distribution is always positive. Okay, you could see this is starting with the 0. So if you're working on the left tail test, that will be chi-square CDF 0 to the test statistic and then degree of freedom. And for the right tail, that will be here, your test statistic, go to 1e99 and then degree of freedom. And for the two-tail test, you have to try both of them because once you find out the test statistic, you don't know that will belong to the left-hand side or on your right-hand side. So if you have a two-tail test, I will try both of them. I assume the test statistic is going to be on your left-hand side. So I'm finding the area from 0 to your test statistic, degree of freedom. And I'm going to try the test statistic that will be on your right tail. So test statistic 1e99 and then degree of freedom. And your p-value, I will pick the smaller one and then multiply by 2 because you have a two tail. Okay, let's try to do the first example. Okay, example 1. A sample of 25 1-year-old girls had a mean weight of 24.1 pounds with a standard deviation of 4.3 pounds. Assume that the population of weight is normally distributed. A pediatrician claims that the standard deviation of the weight of 1-year-old girls is less than 5 pounds. Do the data provide convincing evidence that the pediatrician's claims is true? Use 0.05 level of significance. So we'll be using the X step to perform the p-value test. Okay, so first I want you guys look for the claim statement. Okay, with the questions again, find out which sentence that will be your claim statement. Okay, so this is gonna be your claim statement, right? A pediatrician claims that standard deviation of the weight of 1-year-old girls is less than 5 pounds. Okay, after you find out the claim statement, think about it. Which population parameter they are working on it. Are they working on proportion, mean, standard deviation, or variance? So you can see this is working on a standard deviation, right? So first, write down the original claim statement. Standard deviation less than 5 pounds. Okay, now figure out the number 3, the null and alternate hypothesis. Okay, you should have greater than or equal to for the null hypothesis and strictly less than for the alternate hypothesis. Okay, left tail, right tail, or two tail? Should be left tail, right? Because alternate hypothesis is strictly less than. Okay, now we have the formula for the test statistic. So means you're looking for the number 1 here, you're looking for n, your sample standard deviation or variance, or population or population standard deviation or variance. Okay, try with the question one more time. Find out these 4 guys here. Okay, you should get n equal to 25 because it says sample of 25. This population standard deviation, that will be equal to your null hypothesis, which is going to be 5.0, right? And then the S here, that will be the sample standard deviation, which is going to be 4.3. Significance level, that will be 0.05. Okay, plug in to the formula here. You should get 17.75. Now, distribution here, we are working on the chi-square. So make sure you give me the picture skewed to the right. Okay, don't give me the normal distribution. It has to be skewed to the right. And we have the left tail test. The test statistic, that's a 17.75. So it's gonna be here. Okay. Now we need to figure out what is our p-value. Okay. P-value will be the area of the left tail. Okay, we need to figure out what is this one. Area of the left tail. So we'll be using the chi-square CDF starting from 0. Okay, one more time. Make sure you're starting with the 0, not the negative 1e99. We don't have the negative values for the chi-square. Okay, so 0 cumulative area from 0 to 17.745. And degree of freedom, that will be n minus 1, which is going to be 24 here. Okay, use your calculator to see what you get. Okay, you're going to get this guy. Okay, 0.1850. Okay, the area of the left tail will be your p-value, which is 0.1850. Now, draw the conclusion. Okay, the conclusion for the p-value. So we'll be using the p-value compared with your significance level. Okay, p-value compared with your significance level. So try to compare the decimal from the left to the right here. Okay, 1, that is greater than 0. Okay, so that's a greater than. If the p-value greater than the level of significance, fail to reject. Okay, fail to reject. Now, the final conclusion. So the original claim statement, that is Sam has the alternate one, right? So either number 3 or number 4 conclusion. Then you have a fail to reject. So that will be the number 4 conclusion. That's not sufficient evidence to support the claim that, and then copy the claim statements from here. Standard deviation of the weight of 1-year-old girl is less than 5 pounds. Okay, so now I want you guys try to do example 2. Okay, so this question first, find out the claim statement. So my claim statement should be here. Test the claim that the tar content of filter 100mm cigarettes has a variation different from 0.0625 milligram. Okay, so this is my claim statement. Then again, figure out, are we working on proportion, mean, standard deviation, or variance? So I have a variation here. So this is working on the variance. Okay, so write down the original claim statement. The variance is different from, so that will be variance not equal to 0.0625. Okay, one more time. This is a variation. So I do have the population variance in here. And then figure out what is your null and alternate hypothesis. So you should have equal and not equal to. Okay, and this is gonna be two-tail. Okay, because of the not equal to on your alternate hypothesis. So that's a two-tail. Okay, you have the formula here. So try figure out what is this for, guys, here. Okay, you should get this. Okay, right? This one, for the example one, we only find like the standard deviation because we are working on the standard deviation. Now we are working on the variance. So we're gonna put the variance here. Okay? So now plug into the formula. You're gonna get the test statistic is 15.034. Then sketch the distribution one more time. Chi-square is a skew to the right, okay? Skew to the right. And we are working on two tails. Okay. We don't know like the test statistic, the 15.034 will be close to here or close to the right tail. So what we're gonna do, we'll be finding both of them. We assume the test statistic that is located on your left tail. So we try to figure out the area of the left tail. That's a chi-square CDF from 0 to here. And then degree of freedom, that will 30 minus 1, which is going to be 29. And then we find it out, that's a 0.0153 here. Okay? And then we're going to assume the test statistic that is located on your y tail. So find the area of the y tail. So that will be chi-square CDF from the test statistic to 1e99, and then degree of freedom. So you're gonna get 0.9847. Okay, remember the total area under the curve is gonna be 1. If this guy is gonna be 0.9847, that is not the white tail, not the little white tail in here. Okay, so you're gonna know that your 15.034 should be located on the left hand side here for the left tail. Okay, we're gonna pick the smaller one. So this is gonna be the smaller one. P-value will be equal to this guy multiplied by 2 because I have two tails. Okay, one more time. Try to figure out both of them. Pick the smaller one. And then you're gonna multiply by 2. That will be your p-value. Now compare with your significance level. Okay, compare with your significance level, which is gonna be less than or equal to. So that's a reject. Okay, now figure out the final works. So our original claim should go to the alternate hypothesis. So either number 3 or number 4 conclusion. And we have a reject, so that will be the number 3 conclusion. There is sufficient evidence to support the claim that, and then copy the claim statement here. So this is how we're using the p-value method to do the hypothesis testing for standard deviation or variance. Okay, the next example. This time we'll be working on critical value method. Okay, critical value method. Okay, so with this question first, and I want you guys try to figure out number 1, number 2, and number 3. Okay, so first, find out the claim statement. The claim statement will be here, right? Test the claim that the standard deviation of the speed is equal to 5 miles per hour. Okay, so now we know we're working on standard deviation. So standard deviation equal to 5 miles per hour. Okay, figure out the null and alternate hypothesis. Okay, and that will be 2 tails again. Then find out these 3 guys here. So they given the data, okay, instead of the data. So you know, and you're gonna count how many data do you have. You have 14 data here, and this is a population standard deviation. So that will be equal to 5.0. And sample standard deviation. So try use this data. Okay, plug into your calculator, figure out what is your sample standard deviation. Okay, you will have this one. Okay, right? Number 1, number 2, and number 3. Now, we're gonna do number 4. Okay, we have the distribution. That's a chi-square to the right again. Okay, chi-square, I'm sorry, chi-square skew to the right, And we have 2 tails. Okay, 2 tails. And we have a 5% level of the significance. So since we do have a 2 tails, we have to divide it by 2. So each tail, that will be 0.025. Okay, now we need to figure out what is the critical values. And again, we do have a 2 tails, so we should have a 2 critical values. But this is not the symmetric, not like the normal distribution or t-distribution, okay? This is not symmetric. So we have to figure one by one here. To find the critical values, we will be using the same method under session 7.3. And on the session 7.3, we introduce like 2 methods. First one will be using the chi-square distribution table, just like this table, the table A4. Or you can use the calculator to find the critical values. You only need to pick one method, either the table or the calculator. And this video, I will be introduce both of the methods. So first, let's use the chi-square distribution table. On the left-hand side here, this is the degree of freedom. Okay, you know how to find the degree of freedom, right? That will be n minus 1. And then you're gonna see this number on the top here. This is talking about the area from the right, okay, the area from the right. For example, if the white tail here, this is a 0.025, you're gonna look at the 0.025 in here. And then finding the degree of freedom, that will be the critical values to the right. And if you want to find the critical values to the left in this point, you need to find out the cumulative area from the right here. Okay? And then all these 3-digit number, this is talking about the critical values on here, on this number 9 here. Okay, so for this example, our sample size n is equal to 14, so the degree of freedom will be equal to 13. So 13 will be like these numbers here. Okay, let me make it bigger. Okay, right here. So there's a degree of freedom here. And then first, let's find out the critical values to the right in here. So look at the degree of freedom is 13 and the area to the right is 0.025. So 0.025. So the first critical value will be 24.736. Okay. Chi-squared to the right will be equal to 24.736. Now, let's figure out what is the critical value to the left in here. So first, figure out what is the area from the right here. So we know that the area in the middle should be 0.95. Add up these two numbers, that will be 0.975. So 0.975, and then degree of freedom is going to be 13. So the chi-squared to the left, that will be 5.009. Okay, so write it down. This is two critical values. You could write it down from here also. Okay, just write down the degree of freedom, the chi-squared to the left, and then chi-squared to the right. That will be your critical values. So this is how I used the table A4, the chi-square distribution, to find the critical values. And if you want to use the calculator, so use the calculator. First, click on the math, go up, then you're gonna see this guy, the softener. Okay, we try to solve the equation here. Okay, we will have the equal to, 0 equal to. Go to the chi-square CDF. So second vase. Choose the chi-square CDF. And then, let me show you here. So here, the chi-square to the left means like here, okay, this one, the critical value. Starting from 0, okay, starting from 0, comma, the x here, this is what we want to figure out, okay? This is gonna be my critical values here. So I'll be using the one next to the alpha. You're gonna see that's x, t, theta, and n. So click on this guy, that'll be the x. Comma, this is the degree of freedom, so that will be n minus 1, so which is gonna be 13. Okay, and then minus the area from the left. Area from the left here, that's a 0.025. So 0.025. Okay, plug in here the whole thing on your calculator. And then enter. You're not done yet, okay? So here, we're gonna click alpha, and then enter. Now, you're gonna see this is warning. Okay, they are calculating. So this is a chi-square to the left. The critical value will be equal to 5.0087 or 5.009. Okay, this is a chi-square to the left. And then now we need to figure out what is the chi-square to the right. Okay, chi-square to the right. So in this window, I could just go up. Okay, go up back to this one, back to this screen. Okay, this is how you guys find the chi-square to the right. The only thing I need to change, that will be the area to the left, okay? Because we want to figure out from 0 to the x. This time will be this guy, the chi-square to the right here. Degree of freedom is going to be the same thing. I only need to change the area from the left, okay? One more time, we want to calculate this guy. So the area from the left, that's including the left tail, that will be 0.975. Okay, enter. Then you're not done yet, okay? Make sure you click on alpha, enter. And then now they are calculating, they're working right now. Okay, you're gonna see the answer 24.736. Okay, this is gonna be chi-square to the right. Okay, so we have these two values. This is gonna be your practical values. Then find out the test statistic. So plug in this to your formula. You should get this one. Okay, and then conclusion. So the test statistic is 11.008. It is the test statistic located in the inside the critical region or outside the critical region. Okay, so this guy should be outside the critical region, somewhere like here. And if your test statistic located here, that will be fail to reject. And then conclusion, it has to be either number 1 and number 2, right? And you have a fail to reject, so that's a number 2 conclusion. Okay, that's it.